Okay, and if for any reason the screen becomes blurry, again, find a way to let me know, because I wouldn't know unless you see. So, well, hopefully, I was kind of ambitious. I wanted us to do 3 questions, but with the way things are going now, not sure if we'll be able to cover everything. But at least let's try and do the vectors question. We did this really early up in the term, so it might be a good reminder. All right, so if you remember when we talked about vectors and finding the resultant of vectors, this question is one where you need to find the resultant of a vector. So the figure below is a vector diagram representing the velocity of a basketball, OA. So this is the OA vector. And the wind's velocity, this is the OB vector. Now the question says, by making an accurate scale drawing on the figure below, determine the resultant vector. I'm not sure how many of you were actually here for this part of the class, but this is how we needed to do it, right? We needed a, I always mix this up. I think this is a compass. So this is your compass where, you can open the compass to however, wide you want it to be. And then, like, you can mark a line and so forth. Just erase the line. Okay, so how are we going to do it? What we need to do basically is complete a parallelogram. That is what we're going to use the compass to do. So to complete the parallelogram, we need to like duplicate this OA vector onto the tip of the OB vector. And the way we're going to do it is by using the compass, placing the point at O, and we need to just turn this a bit. We open the compass to the width of the line, right? Just want to get this thing a little straight. Right, that's a little better. So when we have that, we take the tip of the compass and we place it at B. And then we're going to just mark an arc. Okay, so we mark an arc. And then we're going to do the same thing for this vector OB. We're going to project this OB vector onto the tip of A. Using the compass again, we need to basically decrease the compass to the length of the line. We need to turn it a bit. You would do this same thing with your actual compass, but it will be a little easier for you. And then we place the tip at A, and we want to mark an arc. Good. So now the intersection is the intersection of the two vectors. Okay, so to complete the parallelogram, right, we use the ruler. Just kind of bear with me a little while. And we just draw from B right on to where it intersects, and then do the same for A. Can get this thing to turn. Alright, I think I might have it now. So this essentially is our parallelogram. What we are interested in is the distance from O to this new vertex that we just created. I mean, you can call it D or something, but let's just draw the actual vector that we're interested in. This is the resultant vector that we're interested in now. From O to are you guys following? Alright, so let's just use just use this. Ouch. It's under. Okay, so that's the vector I'm interested in. Okay, good. So what we have is that this line is the resultant. This is the resultant vector. There. If we measure this line using the same ruler, we will get something like 17.5. It looks like 17.5. So that's the length of the line. But if you notice, you just write 17.5. So the length of the line is 17.5 centimeters. But the scale tells us that 1 centimeter is equal to 3 meters per second. So therefore, if 1 centimeter is equal to 3 meters per second, then 17 centimeters if it's above there, 17 centimeters is equal to 17, actually 17.5, 17.5, or 17.5 times 3. How much is that? I'm using my phone. So that's 52.5. That will be meters per second. So basically the resultant velocity in this direction is 52.5 meters per second. 49.5, did I make a mistake? There's a calculator here. Okay, good. So I didn't actually make a mistake. Let me just get rid of this calculator. Oh, okay, good. So now that's the resultant vector. What we also need is the direction, because it states its magnitude in meters per second and its direction. If you remember, a vector isn't completely described unless you state the magnitude and the direction. To get the direction, that's why I brought in the protractor. So the direction that we're actually interested in is, we just need to know what angle. Oh man, just messed it up. We just need to know what angle this is. Right, so we would use the compass. And I mean, it looks right off the bat like 25. I can zoom it in if you're interested. Zoom this in. So, I mean, zooming it in, it looks like 25.5. Yeah, but we'll just say 25 for tonight. So the angle, so we can say that the resultant vector is 52.5 meters per second at let's say 25 degrees to the OA vector. Okay, if you have any questions, let me know now. Did you follow? If you follow, you can just say yes in whatever method you're chatting with me via. Just so at least I can know. So Adrian, I think you missed this session. Do you follow? You think you can do something like this again? Okay. Karian, you missed this section as well. Did you follow? Karen, you still here? Okay, I'm not getting a response from Karen. I'm going to just continue. Okay, the difference between a vector and a scalar, and we've been talking about it. We've been talking about it for a long time. A vector has both magnitude, writing bad, magnitude plus direction. Right, and a scalar only has magnitude. And in addition to being able to give you definition for what is a magnitude, for what is a vector and a scalar, you should be able to say which quantity is a vector. So if you could remember, temperature is a scalar, right? Mass is a time, is a scalar. We put it there, I'm not taking properly. Mass, scalar, momentum is moment is a vector, because we're interested in whether it's anti-clockwise or clockwise. Upthrust is a vector because it only acts in one direction, and we're interested in that direction. Force is a vector. And also because upthrust is a type of force, why it's a vector. Momentum is a vector, displacement is a vector, velocity is a vector. Half-life we haven't done before, but half-life basically is time. So half-life is a scalar. Any questions on that one? All right, let's continue. Okay. Okay, this question is a moments question. Right, so a fifth form student perform the following activity to try to determine the mass of a lump of plasticine, MP, right, M sub P. The diagram below shows the setup of the apparatus used. The principle of moments was used to solve the problem. And if you look at the diagram for a little bit, well, the apparatus, you can see the pivot. You can see the pivot here. It's right at the 50 position mark of the ruler. And I mean, as I mentioned, the ruler, if you notice, the ruler just goes from 0 up to 100, right? The results of the activity will be recorded in the table. So you have the position of the plasticine, which is this P here. And these values, if you notice, could adjust the position on the ruler. So 10, 20, 30, 35, 40, 45, they adjust the position, the various positions on the ruler. And then similarly, the position of the 50-gram mass, Q, adjust positions again. So now when they ask to complete the table, because that's what the question says, okay, I actually have the question kind of hidden. Let me just move it a little bit. The question says to complete the table by calculating the values of x and y. So we actually want the distance from this point to that point and the distance from this point to this point. So x is given to us in the first instance and we can verify it. We can verify it because if this is 50, if this position is 50, this is 50 here, and if this position is 10 centimeters, then the distance between P and the middle is indeed 40 centimeters, right? So we verified that, and in the same way now we go and try to determine the value of y. So if the position of Q is 86, so if this is 86 centimeters and this is 50, then y is just 86 minus 50, right? And we get 36. So y is 36 centimeters. We applied the same principle to work out the entire thing. So for the second instance, when Q is 76.2, just erase this. So if this position is now 76.2, because this is the position, it's like this position here is 76.2 centimeters on the ruler, and this position on the ruler is 50. The distance between these 2 points is the subtraction, 76.2 minus 50.0, that is 26.2. So y is 26.2. You do the same thing for all of them. I'm going to do one more and then move on. So if the position, include the screen a bit. If the position of P is 30, if that's 30, and then this is 50, then the difference is 50 minus 30, right? That's 20. Okay, 20.0. And you will notice because it's 30.0, that's the position, right? Did they because they gave these two values as 40.0 and 30.0, it will make you believe that this point is 50.0. So when you're doing your subtractions, you are safe to write 20.0. And I think this one is like 15.0. And similarly, what you do is, actually I messed up my pointer. You try to keep it to the same accuracy level. All right, so I did this before and came up with these values. Just check to make sure you guys are following, right? If you're not following at any time, just send me a chat message. Okay, so these were my results. These were my results. Notice everything is to one decimal place. And then the next question says, use the table of the completed results to plot a graph of y against x. Now, whenever you see this say plot y against x, or sometimes they say y versus x, put whatever is in front on the y-axis and put whatever is behind on the x-axis. It's kind of clear in this instance because they use y and x. But I mean, it could have been force versus mass. So you put the force on the y-axis and the mass on the x-axis. Okay, and I drew the graph and plotted the graph before, just to save some time. Also, this is your graph. And I wanted you to make some notes and try to remember when you're drawing your graph, some of the things to remember when you're drawing your graph, right? I'm going to maybe highlight them. Remember to give your graph a title. 1. Remember to give the graph a title. Remember that when you're plotting your points, try to circle your points. I would advise that you always circle. When you're using a dot, circle the point. If you're using an X, circle the point as well. That's just to make sure that it's visible. What else do I have? So this was the second point. 2. Try to use up more than 75% of the graph paper, because you don't want a graph that only fills up a small area. You don't want a graph to fit just in this region here. You're trying to get the graph to fill up something like that. Actually, I had to flip this graph sheet because I was ending up with too small a graph. So if you have to flip your graph to get a better scale, so it uses up more, then you can go ahead to that. So this was the third point. The third point is use 75%. Use 75% of graph paper. Of paper. Remember to label the axes with both the quantity and the unit. Remember to label, and I think the last thing is just remember to give the scale. So that's 5 points. Listen, if you do this, you will get full marks on your graph. And then in addition, of course, you must plot the points accurately. All right. But you can easily lose marks if you just forget to do these. Or let me say, you can easily gain marks if you just remember to do these things here. You can easily gain marks. All right, so that's the graph. Okay, and then they said you needed to calculate the slope. They said, remember how to calculate the slope? You need to draw a fairly large triangle. So you don't want a small triangle using up like 2 points I want to make. You don't want a small triangle that looks something like this. You don't want that. You don't necessarily want to use the points plotted. That's not your aim. Your aim is to use any point, right? The aim is to use any point on the line as far apart as possible to give you as large a triangle as possible to find your gradient. All right, so this is the better thing to use. Let me just fix that. This is the best size triangle to use. These two, not so great. Okay. Where is my, tell me I deleted my, oh my Lord. I deleted my graph. Oh my Jesus. All right, it means I'm going to have to find, I'm going to delete these things. Okay, for convenience tonight, let's see. I want to use, let me zoom it a bit. I'm using this point here. It's hard to draw this line. That's why I drew it before, but I deleted this slide. Okay, bear with me for a little bit. Okay, let me try and get this thing done. Okay, it's not cooperating. Let me try the ruler. Okay. No, actually isn't 100% straight. I'm gonna stop somewhere here. And then just flip it a bit. Let me do that again. Let me get this thing right. Let's try this again. Okay. So this is what you actually want to do. You draw a large triangle. And then you determine what your points are. So this point up here is, let's just move this around a little bit. This line is actually 40. I think that's 39 on the X. So this line here, that's 39 on the X. And let's say 39.5. It's 39.5 on the X. And on the Y, it looks like that looks like 35. I hope y'all not getting tired. All right, we're moving along. We need to get the second point. So this is 5. That looks like, let's just say about 6 on the x-axis. So this point here looks like 6. It really should be, I mean, if I'm going to say it's exact 6, I really should be writing 6.0, you know. 6. And on the y, that's 2.5 here. That's 3. 1, 2, 3. Let's do that again. 1. The solid line is 2.5. That's 3. That's 4. That looks like 4.25. But because we only have an accuracy of 2 decimal places, we're just going to write 4.3. Right? So these look like my values. Okay, let me just zoom it out and then continue. Right, so if these are my values now and I want to find the gradient, if you could just remember that gradient now is y2 minus y1 divided by x2 minus x1. Let's move this really over here. So that would mean 35, and again, if I'm saying it is exactly 35, I can mean 35.0 minus 6.0. I apologize, it becomes the writing. X2, did I do that correctly? Yes, 39.5 minus 6.0. No, I made a mistake. It's actually 35.0 minus 4.3. Okay, so what we end up with there? $35 minus 4.3. I'm using my calculator there, so I don't make any mistakes. 30.7 divided by 39.5. That should be easy to do, but I'm not thinking. 6, that's 33.5. 33.5. So let's divide 30.7 divided by 30.7 divided by 33.5. So I got 0.9164. One question is how accurate? Okay, how accurate do we give this? We've been working with 3 significant figures. So let's just keep 3 significant figures. So let's say that the gradient is 0.916. Let's look at the units, because the unit for the gradient is usually important. But for the whole time, we've been dividing centimeters by centimeters. So we're going to do it up here. If we divide centimeters by centimeters, they both will cancel. So the gradient has no units. You can just simply write the gradient is 0.916 and not use any marks. It's dimensionless. All right, so if you could just remember that number, because we need it, I think, for the next slide. 0.916. All right. Use your graph to determine how far the 50-gram mass needs to be placed if it balances when the plasticine is placed at 27.5 centimeters on the pivot. Let me ask you guys following? Any questions? It's 8 o'clock now. Are you guys still here? Okay. All right, let's continue. Use your graph to determine how far the 50-gram mass needs to be placed if it balances when the plasticine is placed at 27 centimeters from the pivot. So basically what this is saying is that the plasticine is 27.5 centimeters. It's placed 25, I think I misinterpreted something. The plasticine is placed 27.5 centimeters from the pivot. So it means that it means that the distance, it means that x is 27.5. It means that this distance here is 27. If it's saying that it balances when the plasticine is placed 27.5 centimeters from the pivot, it means that this distance here is 27.5 centimeters. Right? So you basically need to use the graph to determine what is the value of y for x equal 27.5. Let me go back up to the graph. What is the value of y when x is 27.5? Let me zoom in. 27, that's 25 here. This is 25 here. And two of these little things is 1. So we are interested in, which is 25, is 26. Can't really see too well. This is 26. That's 27. This is 27.5. So I'm actually interested in this point right here. Just shift around this thing a bit and see what I get. So I'm interested in this point. I'm interested in this point right here. Now for me, 4 of these things is 1. So this actually is 20. This is just now. That's 15. Okay, so 2, 3. That's 2. That's 3. That's 4. It's actually 24. Just check it and make sure that it adds back up. That's 25. And so that's correct. So it's 24.0. If I'm to go back to the other slide. So according to the graph, y is 24.0. But the question asks, determine how far. Okay, you can say, okay, the question asks, determine how far the 50-gram mass needs to be placed for it to balance, right? So you can actually say 24 centimeters, 24.0 centimeters from the pivot. That's like how they stated their case. Or you can say 50 plus 24 is 74. You can just say at the 74 centimeter mark. All right. So that's that. Any questions with that? Any questions there? For those I see like you're just joining in, I'm not sure how long you were here for. We're just wrapping up the second question. Okay, let's continue. Okay, so state the principle of moments. If you could remember this. What does the principle of moments say? One of y'all could put it in the chat. Principle of moments. Okay, I'm not getting any responses, so let me just continue. The sum of the anti-clockwise moments about a point equals the sum of the clockwise moments about the same point. All right, and remember to include about the same point. Don't just say that the clockwise moment is equal to the anti-clockwise moment. You have to include about the same point. Okay, so this last part of the question now says that the weight of the plasticine WP is related to the weight of the 50-gram mass WM by the formula WP equal to the gradient times WM. It just says determine the weight of the plasticine. So just using the value that we got for the gradient earlier, I think we got what, 0.961 or 16? 916. So just plug in the values. So the weight of the plasticine is 0.916 times the mass, 50. So that's 45.8. 45.8, and it actually says that that's the weight, so that's newtons. Calculate the mass of the plasticine, and we know that the weight is calculated with this formula. W is equal to mg, so if we just rearrange to make m the subject, we get weight divided by g, and notice they give you what g is down here. So the mass is 45.8 divided by 10, and we get 4.58. This would be kilograms. All right, this will have to be kilograms. Whoops. All right. I'm shoving with my little pen tool. Let me just clean this up a little bit. All right, so that's that. I think that's the end of that question. I don't think we have another. Okay, so the last question is, I think we still have maybe about 5 minutes. Okay, great. You guys are following. Okay, last question. This question is on Hooke's law, right? So a private student studying CSEC physics, his name is Nielsen, wanted to convince his younger brother that rubber bands do in fact obey Hooke's law and they extend in proportion to the applied force when stretched. Describe clearly an experiment that Nielsen could perform to convince his brother. And then they say, include in your answer apparatus list, a description of the procedure, and the observations to be made. Okay, so the apparatus list. What all we need? We can think about it for a little while. Okay, I had saved the answer to this, so I don't have to do all the typing. Well, if I can get this thing done. Okay. So the apparatus list. What we need some sort of a ruler. We need the rubber band. We need a clamp stand. I'll show a picture just now to make sure we can clamp the ruler and the rubber band together. We need a pointer. We could use like a paper clip and straighten the paper clip. And we need like a set of known masses, so like maybe like 5 10-gram or 6 10-gram masses. That will do. And the description of the procedure. How would we, let me just change the color of this thing. How do we go about, because essentially what we're trying to do is just prove Hooke's law. So are you thinking about it? And if you remember what Hooke's law says, Hooke's law basically says that the extension of a spring is directly proportional to the stretching force, right? The extension of the spring is directly proportional to the stretching force. So what Nielsen needs to do is to just perform an experiment where he can measure for various values of forces, the different extensions, and then see if the force is directly proportional to the extension. That's all Nielsen really needs to do. So he has a list of equipment and the procedure. I'm just going to cut and paste my procedure, make it easier. All right, so that's my procedure. And I had an image to bring in just to make it sort of clear for anybody who wasn't really sure. If you could just give me another second here. Applications and pictures. Okay, good. So I have a image. It's not 100% clear. Let me try this again. No, I am clear as well. All right, super. Okay, so we want to set up the clamp. We have just like an image of a clamp here with the rubber band hanging from it. I mean, this image just shows a spring, but you just replace this spring with a rubber band. And when you're actually doing this in your exam, you can make a quick sketch of the diagram because it really helps in ways where you can't find the words to write. So if you find that you are running out of time and you don't have the time to write all of the words, you could make a quick sketch for us and then try to write a description after. So, well, one will help the other. So we have the clamp and we have the rubber band hanging from the clamp, right? And then we have, well, we straighten a paper clip to act as a pointer and we have attached it somehow to the rubber band, right? And then you want to attach the ruler behind the ruler behind the rubber band. Now you want to measure and record the length of the rubber band. That should be the initial length of the rubber band before you attach any load on it, right? Now attach various known masses to the rubber band, increasing each mass by about 10 grams, right? And then for each new mass, record the new length of the rubber band, okay? And then when you're finished now, you're going to plot a graph of extension versus force. So that's the procedure. Is everybody, you guys clear? For those who are asking what is kg, I'm just seeing this. I think I'm running out of time. Okay, let's continue quickly. Okay, so this is your procedure basically. Okay, so that's the procedure. What we want now is the observations to be made. What results, that really is asking us, what results are we going to be collecting? What values are we interested in that will help us to solve this issue here? The values that we are really interested in is not so much just the length of the rubber band, but we're interested in the extension of the rubber band. And we're not really interested in just the mass that we hang on the rubber band, but we're interested in the force that, or the weight of the mass. So those are the two things that we need to highlight under observations. We need to calculate the force, or how about if I just see observations that we're going to make, that we need to make, right? First, we want to record the original length in a separate table all by itself. Okay, so record the original length of the spring in a separate table by itself. We want to record the masses and the lengths in a table using a new row for each mass. And if you want to just give them like a, I mean, all you need to do really is just draw a quick table just so that you can show them that you know what you're talking about, right? So a table, what you're saying is to record the mass, right? The mass. You also want to record the length, right? But these aren't just the values we're interested in. We're actually interested in the force created from the mass, and we are actually also interested in the extension. So you want to put that in your table, and you also want to explain how you calculate. You want to explain how you calculate the force. So you would say, sorry about that. Calculate the force using the equation. You know, you give them the equation for mg. Sorry about that again. And then you actually tell them as well how to calculate the extension, which you would say subtract the original length from the new length. And then what did I miss inside here? Record the mass. Okay, basically I didn't miss anything. And then when you finish this now, you would tell them that you plot force versus extension and what to expect. Plot the force versus the extension. And it should produce a straight line. It should produce a straight line. Okay, these are all the questions I had prepared for today. Do you guys have any questions for me in relation to what we did? Do you think it was all right? Let me get some feedback from you guys. Okay, well then, that's it then for today. Thanks for coming. All right, so that's it. We'll see how Thursday goes. Stay tuned to your emails. If you have any questions, please, you can just send me an email or something. All right, so I'm going to stop now and we will catch up on Thursday.